Hi, and welcome to the Azure Database for MySQL monthly webinar. I'm Shreya Aithal. I'm a product manager in the Azure Database for MySQL team. Before we get started, I want to first wish you all a happy new year. Hope you all have a great year ahead. In this very first session of 2024, we want to bring you a special MySQL Experts edition where you'll learn from MySQL community experts some tips and tricks to better work with MySQL in general, as well as with Azure Database for MySQL. Now, here is the agenda for today's special episode. We'll have three sections. Our first guest presenter, Shiv Iyer, founder and CEO of MinervaDB, also a well-known expert and keynote speaker for MySQL, PostgreSQL, and MariaDB. He will walk us through 5 golden steps to follow for effective MySQL troubleshooting, along with detailed instructions and a couple of scripts as well. Next, we'll invite Kyle Joyner and Stacy Minchuk, technical experts from the popular database client DBeaver, who will walk us through an overview as well as how to use it to easily work with Azure Database for MySQL. And finally, as we are entering 2024, I'll walk you through a recap that is a summary of all the feature updates and key announcements from 2023 and share with you a roadmap for 2024 as well. We are live today on YouTube, LinkedIn, and Twitch. And for those of you who have missed any of our previous episodes, you can check out the recordings on our YouTube channel. Our handle is at AzureDB MySQL. And as always, requesting you all to keep this session as interactive as possible. So if you have any questions or feedback, or you just want to drop a hi and let us know what you want to hear from us in this session or in the upcoming sessions, please drop it in the chat window and we'll address them as we go through the session. We also have our product expert, Sudesh Narayan Swami, on the chat window to help answer any questions about the product that we are unable to address during the session. And we are constantly looking forward for feedback to grow and enhance our user experience as well as our webinars. So we are really looking forward to your comments on the chat. Now, let's get started with the very first session, the first section. I'd like to invite Shiv Iyer, founder and CEO of MinervaDB, and also a well-known MySQL community expert, to walk us through with detailed guidelines and scripts what he calls the golden 5 for effective MySQL troubleshooting. Hi, Shiv. Welcome to the webinar, and thank you for joining us today.
Hey,
Could
Shreya.
Yeah.
Thank you
Please go
so
ahead.
much for the invite. So first of all, very happy New Year, everyone. Thank you so much, everyone at Microsoft Azure team and Shreya, Parikshit, and rest of the team, right, for inviting me for this talk, right? And so when we started the conversation first, and like I'll just do a quick intro, right? When we started this conversation with Shreya and Parikshit, so like I gave 3 topics. One is about troubleshooting MySQL, the top 5 golden 5. So I call it top 5 golden 5. The reason because that often like I've been in the business of MySQL open source database systems for over 2 decades now, right? So when I start conversation with a CTO office to a database engineer, they ask like, tell me what are 5 things you can do, right? Just 5 things, right? How you can do that. So the top 5 golden 5 evolved from there, right? A quick background of mine, like I was the first MySQL engineer joined from Southeast Asia and MySQL AV team. First full-time consultative data SRE for Twitter. I worked even with Percona, Palomino, DB. I currently the founder of MinervaDB and Chester Data, right? I've been like across open source database systems infrastructure on MySQL, PostgreSQL, MariaDB, and ClickHouse, right? Across both OLTP and OLAP database infrastructure, right? So that's my professional background. I've worked with several enterprises, several internet properties, very large internet properties in my last 2 decades of MySQL engineer, data engineer roles, right? Across the functions. When I say across the functions, I've been a database architect, I've been an engineer, I've been a data SRE, I've been a data ops guy, on call, right? So predominantly the focus has been always about performance and scale, right? More on troubleshooting, right? Work on from the consumer-facing internet companies to the fintechs, to the ad techs, OEMs, some of the largest payment integrators globally, which includes Swift and which is for the global financial intermediary service handling. Also UPI for India, right? So this is my background on professional interest, and so I talk with the agenda of the talk today. Like I said, right, the whole objective. Shreya, you can go to the agenda of today's talk. Thank you. So the whole agenda is that what are those top 5 things which I remember when I go for talking to a customer, right? How does this all begins? Uh, so I'm not reading through the deck. I mean, I'll give the talk over the deck. My deck will be definitely available for you to download. Also, the scripts which I use for troubleshooting, at least for the preliminary performance audit. Because when you talk about troubleshooting, this is a job of a detailed forensics diagnostics activity, right? Like you need to collect the data, like the evidence is important to decide that what are you going to do with your database, right? So how do we start? We start right from the infrastructure, right? First, before defining the goal of your database infrastructure, we need to know that what's the capability, what's the throughput of this infrastructure we are building, right? The capacity planning sizing is something which comes as one of the most important tasks, which every MySQL infrastructure I work very closely with. This is to make sure that we are setting the expectations clear, right? If you have a larger database, of course, we need to build the infrastructure for that, right? There is no magic system variable which you can set that, hey, move fast, right? That's not there. Also, building the Linux for that, right? The impact on the performance on tuning the Linux is sometimes even beyond what you have, kept as your golden rule. Like for example, I've seen that transparent huge pages. Database don't need a transparent huge pages, right? So disabling that makes a immediate, instant gratification kind of a performance, right? Swappiness. So I'm getting into a stage that from the hardware to the infrastructure to the Linux, then to tuning the server, right? The goal here is that one, identify your infrastructure for your load. Two is build or tune your Linux for that. The third one is that how are you provisioning the resources to your MySQL server, right? And then understand that what is going to be the application. Get into understanding about which are the SQL constructs, the data access path, which are going to be longer and deeper and intense, and which are the large data objects and how the index operations work like, right? Next talk. So what this talk isn't about, right? I'm not talking about a hands-on performance engineering lab. I'm not even talking about what are the application development best practices. Not a DBA session, and also isn't any recommendation from MinervaDB on MySQL troubleshooting. So like I often say that the talks are about the experience, right? The experience experts, right? As what we talk today is not what we are going to use as an experience to troubleshoot, right? So this is purely the knowledge one. Like you want to use the scripts, of course you can use it, but be aware that what the scripts are run, right? So the most important activity I've seen professionally is that when I talk to any MySQL property owner, right, the performance, the speed, right? When you accelerate your database, you are accelerating your business, right? So my audience, though, it begins with the CTO office. Later, it moves to the business and the CEO office and other stakeholders. Reason because when you make your database faster, you are making your application faster. You are making customers more successful, keep them more engaged. We all play games and we like faster gaming infrastructure. We are like on a consumer tech front, like we like everything move faster, right? Like to shop on a faster site, go for a travel booking on a faster site. So the speed is everything, right? So if speed is just a limited scope of user experience, it is where it begins with. But the speed, the accelerated systems accelerates the growth of your business, right? So the golden five, like I said, right, begins with building the infrastructure. The next is like know your Linux build, right? If you have a scope to make your Linux optimized for your MySQL, don't miss that. And the answer is yes, we can tune the Linux for MySQL. Identify what is your MySQL growth, right? How big your database can be. And this cannot be a one-time job, right? When we start, like definitely we'll not have much data, and there will be no compliance. Like I often say in my talks, none of our customers, none of the engagements I've did, right, they never had any issues till the data get in, right? Till there is no data, like till there is no data, everything is good. When the data gets in, that's when people complain about, like I have a slower MySQL server, right? And this leads to everything, right from the data architecture, design, build, the SQL construct, how is the SQL data distribution, access distribution looks like, the intensity of the disk IO happening, right? The next one, right? This is my favorite diagram. Shreya, we can move to the next diagram. Okay. This is one of my favorite diagrams, right? I tell you why. This pretty much captures about what is the roadmap of a MySQL performance audit look like, right? It originates from suboptimal MySQL infrastructure to the expensive queries, right? Often oversized, undersized, both oversized and undersized database objects, the schema objects, will eventually have expensive query operations. And it's a natural tendency that when a database is not performing fast, have many indexes. There is no restriction, right? Like nobody says that, like there is no golden rule in MySQL world that, limit the index, right? So every engineer, every developer find an index for their query is a right decision. When that is allowed and approved, right, you end up in seeing many indexes happening, right? And everything leads to the expensive disk ops, right? It looks, the last box in my diagram is the expensive disk IO operations, and that's where the core epicenter of the problem, right? When you access the disk quite frequently, that results in high latency query operations, right? When your latency of the query goes higher, then it's a tendency that it's about changing the wheel of a running car, right? Some point of time you realize that, hey, something, it's a time for us to horizontally scale MySQL, right? So here we are actually treating the symptom, not the problem, right? Like what are we trying to do? We are adding more MySQL, right? The problem remains. We add more MySQL. We split the data ops read, the reads across many infrastructure. And eventually, right, these all look like interim solutions, right? You will have this get solved for some time, then a new problem will come up, right? About how is your partition model looks like, right? So when you build a schematic representation of your database architecture, right, where do you start it, right? Next slide. Okay, so when you get to infrastructure, this is something which I've spent many days on the debates, right? Faster CPUs, several CPUs, right? It's a very interesting one. It depends, right? I'm not saying that use faster CPUs for everything, or like several CPUs solve many problems, right? In my experience, especially when I'm working with the consumer-facing internet companies' database infrastructure, for me, the faster CPUs really works optimal when you have when you're looking at the performance of the independent queries, individual queries are crucial, right? And also, like if you are looking at improving the disk operations performance, if you are looking at like a faster index operations, faster online schema change operations. Those scenarios works really, really fast. The case will be slightly different if you are looking at parallel processing capabilities. If you are ever using MySQL for a lab, right? People use MySQL for a lab, right? There are cases where people use MySQL for OLAP, where they use like, hey, those are the read instances, right? For them, like that, in such scenarios, right? Several CPUs work. Building MySQL for a parallel query objects model, right? That really works good, right? So there is no right one single answer, right? Again, it depends on how your database look like. If you are looking at a very fast transaction processing system, right? Every single query performance is very important for you. Order processing, right? For most of my e-commerce customers, my ad tech technology customers, for them, it's about the transaction processing model, right? As fast as possible, create orders, right? Or gaming companies. I work with many gaming companies. I worked in the past with many gaming companies or fintech. For them, it's all about the faster isolated transaction completion, right? That is the faster CPU works. When I'm working with the SaaS companies, right, they have a lot of sort search intensive query operations. They want to look at like how the data reporting infrastructure represents to some of the functions. For them, it works with several CPUs ecosystem, right? So, like I said, like as a database engineer, right, I start my, like my first piece of work in every engagement is like understanding the data access path. So when I understand the data access path, right, it gives me the clarity about what is the direction I'm going to take. Shreya, next slide. All right. So I said like MySQL is memory intensive, right? It works great on a larger memory infrastructure, right? Its answer is also quite direct. Originally, or even today, MySQL is a database for many of the internet properties, right? Which could be in the form of a simple WordPress to many internet applications where you read more and more, and reading from the memory from the RAM is always faster than to the disk. So the whole goal is being like how big your database can be. Can we get as much as your database to the available RAM? Invest on a high performance RAM, right? And can we identify that and cache your data objects, right? That's it. In about how do we work on the sizing of your InnoDB buffer pool size, right? It's a general rule of thumb, but then make it 70% of your database size, right? Yes and no, right? I don't believe in professionally. I don't believe in the golden thumb rules, right? I believe in the golden rule of matrices, but I don't believe in the thumb rules. Actually, why, right? Shreya, you can go to a diagram of infrastructure capacity planning sizing. The next one, okay. So let me tell you this. Like one of my customers in the past, right? They wanted to build a very large MySQL database, and the 70%, 80% of your RAM is for DB buffer pool, right? They had a database of as big as like 250, 300 GB of database, right? And they had like 512 GB RAM, right? They just directly kept 70-80% of it, right, of the RAM. It was the database was performing pretty well, right? And this is the right thing to do. Like the entire data got into the RAM, everything. But then the point was that they never planned for how big the database can become, right? So typically what I do is like when the database gets bigger and bigger, I get I build MySQL horizontally. The reason because if I find again, this is about the classification I do when I'm building a very ultra low latency database infrastructure, right? I'll break that into three clusters, primary clusters, where the latency is unacceptable, right? It's about say about a gaming one, right? When I'm playing the game, I need to pick up article and I start playing. So all these, the ad conversion, everything should happen very quick, as fast as possible, right? And when you don't build a capacity of how big your database can be, and when your database performance is the key of the business, then you got to build a database infrastructure so that your primary database will be on your RAM as much as possible. Then the older ones, which are like not frequently accessed, they'll be replicated to a replica instance. And the third one is the failover. So my database infrastructure always look as three. I'm not saying three node, the three layer of clusters, primary clusters with the hot objects where the data is accessed quite frequently, and that will be cached in the RAM. The secondary one, 30 to 40% of that will be on the RAM. The remaining will be on the disk. The failover will be a much lower instance. The whole goal is that not just setting once a large InnoDB buffer pool size and just forgetting it is not scalable, at least if you're building ultra low latency infrastructure. So I would say that don't go by the thumb rule. Build the infrastructure for the performance, right? So what I look forward to, Shreya, next slide, okay. So what I look forward always is that how I can get as much of data can be from the RAM, right? Typically, I compare the read request to the actual reads from the disk, right? A higher ratio of read requests to the disk really indicates that we have a well-performing buffer pool, right? That's where your data is there in memory, like I was saying, right? Identifying where your data lies in is very important, right? And always, invest on the primary cluster of your database infrastructure on a higher performant RAM. I move to the scripts. 2 slides after that. My scripts for monitoring the memory consumption. So these are the 2 scripts which I use. So all my scripts are SQL scripts, right? The SQL ones. Very minimally invasive, right? There is no agents, nothing. This helps you to understand how your available RAM is consumed by MySQL, right? And the matrices which I use, like what is the InnoDB buffer pool usage? Like I said to you, like I don't believe in the thumb rule. When I get the evidence, based on the evidence, I size my database, right? The next one, like I said, like faster SSDs for a web scale really works fast, considering the IOPS, as well for the time to recover. This is very important. Like basically, when people ask me like why SSDs, so is it only for performance? I said no, not just for performance. There are 3 major reasons. One is about the faster business completion. That means like the high-speed data access. The second one is like the IO efficiency, right? You're not investing more on the cost of IO. The third one is about the reliability and durability. It's about the time to restore in case of an outage, right? So how we can be as database systems goes down, but then when it goes down, how do we come back as fast as possible? The next slide is about how do I build my Linux server, right? Like I said, right, Linux has a natural tendency to swap out everything, not just MySQL. It can be PostgreSQL, it could be a ClickHouse, it could be a MongoDB, anything. Linux naturally swap out everything, anything and everything, right? So how do you keep the swappiness as low as possible? Don't make it 0. I've seen people making it 0. The greed is no good, right? Even in database systems world. Making it 0 means your server believes that you have an unlimited, like memories available, right? So that will just bring down your database permanently. Maybe it causes severe damage, very expensive for recovery, right? Restoration. Max open files again. When you're looking at a very high concurrency database infrastructure, I tune the max open files. This will reduce the IO latency. The network infrastructure, I work on the timeout, TCP timeout parameters and the recycle one to optimize the TCP/IP performance. But this is something which you have to be very careful. This works really like magic on a very high traffic internet property, but again, too high is not too good, right? too much is not too good here, right? The CPU usage, how do you use it? Setting up the nice levels to prioritize the MySQL processes, right? It's about, again, unless you understand there is going to be a CPU intense infrastructure, I would say sometimes don't even touch it unless you have expert guidance on that. Next slide. Most important, monitor and tune. Don't tune without monitoring, right? The CPU affinity, right? So you said it very carefully. If you are looking at building our database infrastructure is going to use MySQL infrastructure is going to use CPU efficiently. Your application is designed for a partition, parallel SQLs running on it, then you can work out on affinity, right? On an 8 core, it's like I use a task set of 4 cores. This is very pessimistic, very conservative value. Can be aggressive, but should be very careful, right? So the thread operations, like everything in MySQL MySQL makes a relationship, the connectivity to the application. Your SQL works with the database through threads, right? You can go to the diagram, which is about MySQL tuning and configuration, right? When you're troubleshooting a MySQL performance, from a performance engineering background, 3 most important matrices you need to look at is how expensive are your application queries? How are you tuning them, right? Do you have the list of top 5 most expensive queries by response time? Of that, how many of them are falling on the bucket of full table scans, which causes a very high disk I/O operations, complex large join queries. And so that means that either your MySQL is serving some request or it's waiting for resources. These are the only 2 possible scenarios, right? When you say that I have a performance bottleneck in my MySQL infrastructure, that means that either your MySQL is the request, the query request, during the peak load that can be very high, or the MySQL processes are waiting for the resources for that. The third important aspect is about the indexing, but that is a combination of both, like expensive indexing, bad indexing. There's nothing bad. There's like expensive, unused, or used, right? Expensive indexing and unused are very tricky to troubleshoot. The reason because that you will have the index, your query still works bad, right? So you need to isolate and identify where is the epicenter. The next metrics. So how do I troubleshoot the MySQL thread contention? I look for the log time. Like I said, right? How much DB, this is the default storage engine, is waiting for the MySQL resources, right? What is the thread volume, right? How many threads are running currently? How the available RAM is used by InnoDB buffer pool, if there are any deadlocks, and what is the checkpoint frequency and the transaction history. So the whole goal of mine is about how the resource adoption happening, how is the query distribution happening, how is the index efficiency, and are we locked for the resources. The next diagram is about how the thread operations in MySQL are distributed. Like I said, right, everything which happens both internally and externally on MySQL world is through threads, right? When I say internally, it's about the transaction log completion, the resource access controlled by the MySQL lock mechanism. The query operations from via MySQL buffer pool, right? Or the log transaction completion, right? Everything is about the thread efficiency handling. So the next diagram, which talks about how the threads operates within MySQL, right? This is why I said the threads are busy processing the request, or threads are waiting for the resources to process, right? These are the only 2 states. So identify as early as possible. The next diagram, which talks about which is about on an inverted tree structure of how the MySQL thread operations looks like. Like I said, right, busy on waiting for the resources, busy serving on the transaction completion, and about the query efficiency. Everything is linked to the thread ops, right? So these are my collection of scripts for the thread ops. I got to accelerate. I got only 5 minutes. So the most important thing is like I often say about how large objects impact on MySQL performance, right? When I have an emergency MySQL performance troubleshooting engagement, where I have the time is very limited, like now, right? I start with identifying which are those top 5 tables, and all my queries will be on those tables, right? Now what next? What's the fastest way to tune a MySQL or any point of time? It's like identify the larger tables, partition them, right? You brought down the crisis under control by 50%, right? Smaller data sets, that's a quick magic, right? But then should be careful, right? On a very large data infrastructure, that also looks very tricky and very cautious things to do, right? Uh, when I work on the next one. So when I work on very large data sets, I'll be very careful about the indexes. Like I said, many indexes and limited indexes both are equally a pain to solve for us. The redundant indexes are often end up in increased disk IO, right? And under-indexed causes again the query latency. So I have scripts to identify. So this works like a checklist for me. These scripts operate in a form of a checklist. I'm happy to share more. If you have I'm very active in the social media, right? You can write to me, my email, everything, right? So identifying the hot IO objects. That's what I said. Like if you know which are those very expensive schema objects in your database infrastructure, isolate them. If you concentrate, if you taper on troubleshooting the performance of those, you're almost on the right direction on troubleshooting. All right, so I move to the 4 critical don'ts for a MySQL production infrastructure. I don't over-index. I'll be very careful. Next, Shreya, next. The next one. All right, so I do what I don't do. I don't over-index. I'll be very careful about. I'm very conservative about indexing. Please, never, ever speculate. Take a risk on your backups, right? Don't overlook the query optimization, right? Means that you have to invest on the query performance, but then tuning the same query many times can result further complexities, right? Because you are skewing the optimizer to build execution plan every time you do that. I would rather say that if you can do it right once and accept the fact that MySQL is not built to handle very large data sets, right? Think about horizontally growing it, archive the data. It works really good. Security policies, last but not the least, never compromise on this, actually. What is the whole overall scope of the performance audit of mine is like understand what is the current state of the infrastructure, right? That's very important. How big your database is. Like I said, top tables. Work on the thread operations, which are very expensive, like identify the expensive SQLs. Disk IO is always, every performance bottleneck will have a disk IO, epicenter there, right? Look at the indexing. Have a clear maintenance operations runbook, right? MySQL performance is never a one-time job. You'll be doing it always. As you do more with your database, get bigger and bigger, it get more complex. Invest on a good MySQL monitoring infrastructure. That's always worth, right? Open source, free, SaaS, anything. But have your MySQL monitoring infrastructure you believe in, right? You can count on. That's very important. With that, fine. I'm closing my talk. Thank you so much, guys. Thanks for giving me the extra time. Like I said, I'm always happy to respond to the queries. Always happy to connect. Look forward to talking. Thank you.
Thanks so much, Shiv. I know, this has been a super insightful talk, and I'm sure our viewers found these 5 steps extremely useful and are wishing that we had more time for you. Firstly, folks, you can reuse Shiv's script as per as your troubleshooting needs. I will share the links here. Yeah, the link to the GitHub repository with all his scripts will be here, and we'll try to upload his slides into this repository as well. And we plan to have Shiv delve deeper into each of these steps a little more in detail in future sessions with videos and demos and more. So stay tuned, folks. But for now, I know there was one question on the chat from Shubham for Shiv. We'd love to take it offline, or like Shiv shared just a minute earlier, you can contact him on his email ID as well. But thanks again, Shiv, for taking the time out to be with us and sharing your expertise and your experience. Thank you.
Thank you. Thank you so much, guys. Look forward to talking. Cheers. Bye.
Moving on to the second topic of the day, we'd like to invite Kyle Joyner and Stacy Minchuk, experts from the popular database and MySQL client tool DBeaver, to walk us through the features of DBeaver Ultimate and to guide us through how to easily connect to and work with Azure Database for MySQL using DBeaver. Welcome, Kyle and Stacy. Thank you for joining us today. Shall we start off with a brief round of introductions?
Yeah, thank you. Hi, guys. My name is Stanislava, or just Stacy, and I work as a content creator at DBeaver. And here we also have my teammate Kyle, our technical support engineer. And today, together with Kyle, we are going to show you how to connect to MySQL database in Azure using DBeaver application. Let me start with a quick introduction to our company and tell you just a little about our main products. At DBeaver, we are developing desktop and web applications for database management. Our multifunctional tools allow users to connect to different types of databases, work with data in a convenient UI, create complex SQL queries, transfer data between databases, and much more. We can go to the next slide. Today, we want to demonstrate you the process of connecting to the MySQL Flexible Server database in Azure using one of our pro products, DBeaver Ultimate. One of the two connection methods involves Cloud Explorer, a feature designed to simplify working with cloud databases. It is only present in DBeaver Ultimate Edition and DBeaver Team Edition, our solution for team collaboration. Cloud Explorer allows you to create Azure, AWS, and GCP configurations and create connections to cloud databases quickly and without filling a lot of files. All you need to do is to create a configuration once, and then you'll be able to use this feature as a centralized control point. During our demo, Kyle will show you this feature in more detail. So we can start the video. Kyle, please go ahead.
All righty. We have two different methods for creating a connection to MySQL Flexible Database in Azure. First, we'll start out with our standard connector. This is available in all of our products, including Community Edition. And then we will work through the Cloud Explorer that allows us a simpler method for connecting to MySQL Flexible in Azure. So we're going to start out by clicking on the Create Connection wizard in DBeaver. We'll double click on the MySQL server connection. And then we'll open it up, and we will have to place our username, password, and host. We'll grab those from the Azure connection page. And we'll look at our connection page. Note that SSL is required. We'll have to add that in on our connection here in a moment. But here's all of our connection information. We'll copy the server name, and then we'll switch back and populate the information here. And we'll make sure and go back and set our SSL. And then we will click Test Connection to verify that the connection is working. And we get a successful connection with information about the driver and the type of server. Click Finish, and now you can see the connection is now in our database navigator. We can open that up to connect to the server. And now we have a list of our databases. We can drill down into the tables, as you can see, and we can get directly to the data. Now let's take a look at the second way using the Cloud Explorer. So we'll go up here and connect or click on the cloud icon, and that'll bring up our list of providers. We'll switch to Azure and enter our client ID and tenant ID. If you don't have those, of course, you can get those from your administrator. Apply that, and now we have the demo section here. We will open that up. And there's our MySQL Flexible Server. We'll go with authentication through the browser. And now we can drag the server right into the database navigator. And we can open that up and have access to this server. It's a much easier way without having to go through all the connection properties, and you can just drag and drop any servers. You can see that you can have multiple profiles with the different cloud providers. Now we'll expand the test database, and we'll create a new SQL script. As you can see, we have autocomplete for your queries. And we can reformat the query. And then run it and retrieve the information. And you can see we can edit our query live with auto completion, and we'll add an order by statement here. Rerun our query, and we've reordered the result set. There are many different operations you can perform in MySQL Flexible with our product, not only SQL editing, administration, user management. There are many operations that you can perform.
Perfect. Thanks so much, Kyle and Stacy, for the detailed walkthrough of the demo. The integration is super efficient and super easy to follow. And I love how easy it is to work with MySQL data using DBeaver Ultimate's features as well, especially the Cloud Explorer, right? So folks, do check out this blog for more details on how to connect to Azure using DBeaver. There are more blogs coming in the next couple of days, and so stay tuned. But thank you again, Kyle and Stacy, for your time with us today. This was super helpful. Thank you.
Thank you, guys.
Thank you.
Perfect. So let's move on to the final topic of the day. I know we are 1 minute to the end of the session, but let's go through the entire summary really quickly, as quickly as possible. I'll walk you through not just the summary of all the features we released in 2023, but also some other key announcements we made and initiatives we released, and finally share with you the upcoming roadmap for 2024. So we've been hard at work to enhance the product experience and make Azure the choice for you for running MySQL on cloud. We had a number of key features being released across security, performance, availability, management, and developer experiences, as well as migration. So we'll go through each one of them individually. Firstly, security, right? After we released the support for customer managed keys and Azure Active Directory, or what it's called now as Azure Entra ID authentication, we released in general availability the private link integration. You can connect to Azure Database for MySQL Flexible Server using a private endpoint, just like you do with any other resource within your VNet using its IP address. Under availability, business continuity, and disaster recovery, we've got a ton of features that we released in the past year, starting with the data out replication, which went GA, which allows you to synchronize data out of Azure Database for MySQL Flexible Server instance to another MySQL server using MySQL native replication, right? And this server can be anywhere. It could be on premises, on VMs, on other clouds as well. And this can really strengthen your hybrid cloud or multi-cloud strategies, as well as help you with migrations if you want to move out of Azure Database for MySQL Flexible Server. We also released features, and do note that whatever's marked in green with a tick mark is in GA, whatever's in the I symbol in blue is in preview, and the lock symbol is in private preview. But universal cross-region read replica was released in GA as well, which is the ability to create a read replica in any supported region, in any region that supports Azure Database for MySQL. With this, you can really strengthen your DR strategy and even enhance your performance, right? Then we had Universal Geo Restore, which allows you to restore your source server instances back up to any alternate region across the globe. So earlier, most of these were paired region restores that were available, but we also released the Universal Geo Restore feature last year. We also released, and this is a little more recent one, in public preview in December, near zero downtime maintenance for HA-enabled servers. More about this will come soon in the upcoming sessions, but I'll leave you at that for now. Then we had long-term retention of backups, which is currently in private preview. Previously, our service allowed for automated backups and on-demand backups to be retained up to 35 days. But with LTR, or long-term retention, you can now retain the backups up to 10 years, which will aid your audit, your compliance needs. We had on-demand backup and restore, which was also released in private preview, which provides an ability to export at moment physical backup of the server to an Azure storage account using Azure Blob Storage, and again, run through a CLI command. Once exported, these backups can be used for recovery, for migrations, for data redundancy, availability, or even auditing and other purposes, right? And then finally, we also released the support in private preview, support for 32 GB storage. So for your business critical SKUs, you can expand your storage up to 32 TB. These are in private preview. You'll have to write to us at askAzureDB for MySQL at service.microsoft.com if you want to test these out. Now, we also released a couple of features to ease the complexity of managing your servers. First one was automation tasks, with which you can manage your MySQL resources more efficiently. You can create tasks for things like starting or stopping your server, or scaling up and down your server. And these can be run based on predefined schedules, right? Then we released major version upgrade in GA, which enables literally a seamless one-click experience to move from your flexible server version 5.7 to 8.0. We also released flexible maintenance options, again in public preview, which allows you to reschedule your maintenance windows. So we already had custom maintenance windows, but if you want to be able to reschedule these maintenance windows, or to a later time, or even instantly initiate maintenance with a reschedule now option, these are the options that are currently available in public preview. And finally, we also released error logs under the server logs feature, which provides you the option to view the error logs up to 7 days to analyze and troubleshoot issues much faster. Now, We also spent a significant amount of efforts to improve the performance of the Azure MySQL servers as well. Autoscale IOPS, which went in GA, which went GA earlier, very early last year, enables you to automatically scale IOPS up and down depending on workload trends. So you no longer need to pre-provision IO or pay for the resources that you aren't fully using. And the second most important and cool feature that we released was accelerated logs, with which you could see up to 2x performance enhancements at no additional cost. With this feature, we also see a significant performance and price performance enhancement over AWS RDS, Aurora, and Google Cloud SQL for MySQL, about which I'll talk again in another couple of minutes. Now, under developer experience, we also built out a couple of connectors and integrations for developers to easily consume and work with data residing in our service. For example, the connector for Power Apps, Power Automate, Logic Apps, and Power BI, which enables you to build end-to-end business solutions with very little or almost no code. And then we also released a MySQL extension for Azure Data Studio. Azure Data Studio is the open source client tool that helps you work intelligently with MySQL alongside your other databases. And these MySQL servers, again, could be on premises, on your Azure VMs, or on other clouds, or even on Azure Database for MySQL Flexible Server. And the coolest feature that we released was the new data API builder for Azure databases, which also supports MySQL. You can easily access Azure MySQL databases via GraphQL APIs or REST APIs, and integrate Azure Database for MySQL with Azure Static Web Apps as well. And finally, and most importantly, we've simplified and improved our migration experience as well, to not only move from single server to flexible server, but also from any external source, be it on-prem VMs or other clouds. You can perform near zero downtime online migration using Azure Database Migration Service or Azure DMS. We also released MySQL Import CLI tooling, which is now in GA for single server to flexible server migrations, with which you can perform entire migrations by running a single CLI command. And what this MySQL import essentially does is it provides a simple and fast migration path to restore source server's physical data files to the target server. And MySQL import can migrate up to 1 TB of data in just around 23 minutes. And this is what we tested out in our internal benchmarkings. And the same MySQL import CLI is also available for external migrations, but that's currently in private preview. Now, this tooling is rather interesting. It will use your physical backup copy stored in Azure Blob Storage. Now, this physical backup copy could be obtained through, say, Percona Extra Backup, stored in Azure Blob Storage, and we'll use this physical backup copy to provision and restore to a new MySQL Flexible Server. Again, this is a super fast migration, up to 1 TB of migrations in around 23 to 30 minutes. Now, apart from these features, and all of these are product features that we released in 2023, we also had a few other key announcements, like the benchmark study conducted by Principal Technologies. We talked about this in our previous webinar in December. This benchmark study showed that Azure Database for MySQL is the industry leader for performance, price performance as well, compared to AWS and GCP. Now, Azure Database for MySQL Business Critical Service Tier is up to 50% faster than MySQL on RDS, and up to 2.26 times faster than GCP Cloud SQL for MySQL. And it also costs up to 54% less than Amazon RDS, and 51% less than the GCP Cloud SQL for MySQL. For more details, do check out the link here, aka.ms Azure MySQL benchmark blog. We also released Azure Database for MySQL Contributor Initiative. So if you are one of the community folks who are enthusiastic about our service and want to help others to learn more and do more with the service, join the Contributor Initiative today. Here's the link, and get recognized for your efforts through an exclusive badge, through spotlights, through collaboration opportunities, and more. You could probably, even contribute and present at our webinars, do videos with us, technical collateral, and more. And the next two announcements, one is on Azure Database for MariaDB. It is on the retirement path and will be retired by September 2025. Do consider migrating to MySQL Flexible Server or Azure VMs today. Do check out this link to learn more about it. And finally, towards the start of the year, we also launched the MySQL troubleshooting series. This is a purely an Azure database for MySQL troubleshooting series, but it also has general troubleshooting techniques from our MySQL experts here in Azure, which provides tips and tricks that you can use to anticipate and address potential issues in problem areas like low performance, connectivity issues, replication latencies, even database corruption. Right? We will share a blog by hopefully by the end of this week with all of these updates and links for easier consumption as well. And finally, I do want to share the upcoming roadmap. Do take a look at all of these features. I think most of these features are either in public preview or private preview, and we have most of the features GAing or reaching their next milestones in this quarter. We also have two other features that are newly releasing, which is the MySQL discovery and assessment and Azure Migrate. So with this functionality, you can use Azure Migrate service to discover MySQL servers in your environment, to assess them by identifying their compatibility to move to Azure Database for MySQL, and even receive compute and storage queue recommendation along with their costs. All of this will be available within a month or so in private preview in Azure Migrate. And the support for Azure Database for MySQL in Microsoft Defender for Cloud will be in public preview in this quarter as well. And we also have a couple of other features like the accelerated logs, flexible maintenance options, and near zero downtime maintenance for HA-enabled servers, all of which will be going GA in the second quarter of this year. This is a brief roadmap. We will keep adding to this roadmap and bring the roadmap to you in our monthly webinars. If you want to try any of these features which are in private preview, do write to us at askazure.db for MySQL at service.microsoft.com. That's all for today, folks. As we close out, I will, as always, leave you with 4 things. First, check out our contributor initiative. So start contributing today and get recognized with badges, with official recognition and more. Second, to learn more about our service, you can use these resources or reach out to us on our email ID. And third, to stay tuned for more updates and announcements, do follow us on social media and subscribe to our YouTube channel. Our recordings of the webinar, as well as every new announcement, will be accompanied by posts and videos on our YouTube channel. Our handle on YouTube as well as Twitter is at AzureDB MySQL. And finally, if you want to feature in our upcoming webinars or collaborate with us on any collateral, fill out this form and let us know. Also, you can use the same form for any feedback on the session, or if you have any requests or suggestions for topics we should be covering in the upcoming sessions as well. That's all we had for today. Thanks all for tuning in. And we will see you all in our next session next month on the 14th of February at 7:30 a.m. Pacific time. Thank you.